By now, you've probably copy-pasted the same useEffect fetch logic into 3 or 4 different components. Every time, you rewrite the loading state, the error state, the discriminated union, all of it. That's exactly what custom hooks are for. In this video, I'll show you how to package all of that into one reusable, fully generic useFetch T hook. Write it once, use it everywhere, and never lose type safety along the way. Last video, we built fetch JSON T and a discriminated union for loading, error, and success. Today, we wrap that whole pattern into a single custom hook you can drop into any component. 1. What makes a hook a hook? Quick reminder, a custom hook is just a regular function whose name starts with use that's allowed to call other hooks like useState and useEffect inside it. That's the entire rule. The magic isn't in React, it's that TypeScript can fully type the inputs and outputs of that function, just like any other function. 2. Building useFetch T, step by step. Step 1. Generalize useUser into useFetch. Type requestState equals status loading, message string, status success, data T. Function useFetch RL string, const state set state is useState requestState loading. useEffect don't set state loading. Fetch JSON T, URL data, set state data, catch error, set state error, message, error, return state. Step 2, use it anywhere. Function user profile ID, const state is useFetch user, /API user. If state status is equal to loading, return spinner. If state status is error, return h2, data name, h2. Function product list, const state is useFetch products.API products. If state status equals success, return spinner. Return ul, HTML map of PKIKP, name. 3. What actually makes something a hook? People think hooks are some special React feature with magic behind them. They're not. A custom hook is just a normal function that starts with use and is allowed to call other hooks inside it. That naming convention isn't just a style choice either. It's how React's linter knows to enforce the rules of hooks on your function. Name it anything else, and you lose that safety net. 4. Returning a tuple versus an object. Step 1. Object return what we've built so far. Const state is useFetch user, URL, state.status, state data, state message. Step 2. Tuple return useState style. Function useToggle initial, boolean. Const value set value equals useState initial. Const toggle is set value to not value. Return value toggle. Const is open, toggle open, useToggle false. Caller can rename freely, just like useState. Notice the explicit return type, boolean equals what? TypeScript would widen this to boolean or anything to void, a loose array where it forgets the order and exact types. That explicit tuple annotation is what makes array destructuring like useStates actually type-safe. 5. Why useState returns an array, not an object? Ever wonder why useState returns an array instead of an object? It's exactly this tuple trick. Arrays let you pick the variable names, const count, set count, because array destructuring is positional. If useState returned an object instead, you'd be stuck with fixed property names, or you'd have to rename them awkwardly every time. That's why almost every single value plus setter hook in React returns a tuple, and it's a pattern worth copying in your own hooks. 6. Recap. So today we turned last video's useUser into a fully generic useFetch T hook, reused it across completely different components, and learned when to return a tuple versus an object from your own hooks. Next video we're going into useReducer with TypeScript, how to type your actions so precisely that an invalid dispatch call won't even compile. If this helped, like, share, comment, and subscribe.